everyone. Welcome to the online video tutorial series of computer network subject. In this video, I will explain the concept of reliable data transfer in transport layer. I am Jishan Sheikh, Assistant Professor in IT/ICT Department of LG Institute of Engineering and Technology. Now, in this video, I will cover the basic concept how the reliable data transfer concept will be working. Before that, in the previous video of transport layer, I will already cover transport layer services, multiplexing and demultiplexing, how it's work in connection less and connection oriented services, and the basic concept of how the TCP and UDP is working. So when we are talking about the basic services, how the data is transferring using the transport layer, our main goal is how the reliably data is transferring from source to destination. So when we are talking about the basic concept of transferring the data between source and destination, then we have to conclude following criteria. So how the exactly reliable data transfer is working, how the connection is established during the building of reliable data transfer, what are the concept of RDT 1.0, RDT 2.0, and what are the protocols are used by reliable data transfer, that will be covered next time. Now, we are first talk about the principle of reliable data transfer. So when we are talking about the transfer the data between source to destination, our data is followed in our application layer. That data will be properly maintained by the transport layer to send the data from source to destination. Now, when the data is getting the port from our transport layer, IP from the network layer, then it will transfer to data link and physical. So ultimately our data is following all these steps. But when the transfer is coming here, main thing is that how the reliably it will follow the unutilize our channel. So that will be a two parts here. What are the provider and what are the services here? So when we are talking about the providing services here, first we are talking about the application layer, that sender and receiver is maintaining the data here, and the transport layer which provide the facility to transfer the data reliably from source to destination. Now we are talking about the service implementation. So when we are talking about the service, our data is transferring by our transport layer, but it transport by our particular physical layer. So mostly we are depend how the physical layer is behaving, what type of nature we are using the cabling or Wi-Fi connection. So it is not up to in the hand of the transport layer. That's why we can say that it is all about the unreliability of our channel. But when we are talking about the task of our transport layer, it followed the following functionality. It takes the data from the application layer, it processes and send to the next layer. The same way at the receiver side, it takes the data from the channel, processed and give to the particular application layer. So this is the basic task performed by our transport layer. Now we will understand the concept of basic principle of reliable data transfer in terms of our particular IDT. So what happened here? This task is divided into the four functions: RDT send, UDT send at the sender side, at the receiver side RDT receive and deliver data. So when we are talking about the RDT send here, so it calls from the above, that is our application layer. So the application layer data will be fetched by our RDT send method. That reliable data transfer the protocol by the sending side. Now the data is processed by our RDT send process and it will send to our particular unreliable channel using our UDT underscore send method. So it is called by our RDT to transfer the packet from unreliable channel to the receiver. So at the sender side, what happened here? RDT send method takes the data as an input. Now next process will be taken by our transport layer. Which method will be used, which protocol will be used, it will be decided by our transport layer. After the process of that particular methodology, our data will be transferred to the particular unreliable channel using the UDT underscore send method. Now, when the data is processed with the help of our channel, at the receiver side, reverse process will be taken. So at the receiver side, first it will take the data from the channel using the RDT underscore receive method. Now RDT underscore receive method take the data from our channel with the help of next level. Now that data will be processed by our transport layer and sent to the particular application layer using the delivery underscore data method. So when we are talking about the RDT underscore receive method, it's called when the backend is arrived onto receiver side. It receives the data, then processed by our transport layer, and delivery underscore data method will be called by RDT to deliver the data to the upper layer, that is the application layer. So this is the basic principle how our data will be processed by the reliable data transfer method. Now next we are moving to how we can build the RDT transfer methodology. So for that we have to understand first this method. So incrementally what happened here, to establish the connection between source and destination, RDT protocol is introduced. So here consider only that at the initially unidirectionally data is transferred here. So we can send data to source to destination at a time or destination to source. But when we are controlling now, we have to control here bidirectionally. So when the data is transferring from source to destination, at that time we have to control. If we are receiving the data from destination to source, at that time we have to control. So we have to control the congestion and flow both the time. So for that we have to understand first our FSM, that is our finite state machine for sender and receiver. So we are considering here state machine by the terms of state and event here. So what the particular state is that when the data is transferring from particular transport layer to our channel, at that time one state is maintained. At the receiver side what happened here, when the data is received, at that time particular state is maintained. And in the background event is happening here. So at the event we can say that receive underscore send, UDT underscore send, that is the event which are occurring at the sender side. At the receiver side, send method and delivering method will be occurring. So when we are talking about the FSM here, so that is all about how the state is moving from source to destination. Here event is causing the state transition, that is called event, and action that will be taken by the state, that is all about the action. Now we are moving to the two versions of RDT. And first we take about the RDT 1.0. So when we are talking about the RDT 1.0, it is all about the how the data is transferring. Here we are not considering the number of losses of packets. Any type of errors will be occurred during the transfer of the data, it will be not considered. It is the basic method how the data is transferring. So here we are separating our finite state machine data into the sender and receiver side. So here sender sends the data into the underlying channel and receiver is read the data from the underlying channel. So what happened here we can see. First, it is wait for call from the above. So this method will be called when at the sender side it takes the data from the application layer. At that time it will use which method? RDT underscore send. In the parameter it will take the data from the upper layer. So here one packet is made by our transport layer using this particular method. So here our packet will be make underscore packet. In the parameter we are passing the data. After process the particular data in the terms of packet, we will send to our underlying channel using our second method, that is our UDT underscore send method. So at the sender side, using these terminologies, we are sending the data. At the receiver side, what happened here? So according to our finite state machine, we are considering this event and particular action. So at the receiver side, our particular RDT underscore receive method will take the data from the channel, then it extract the data from the packet and deliver that data to our application layer. So this is the basic idea how the RDT is working in 1.0. But we have to take care about that in 1.0. There is no controlling on if any bits are changed, if loss of packets are there. So for that we have to understand the second version, that is all about RDT 2.0. So RDT 2.0 is separated both the level at the sender side and the receiver side. So first understand how the process will be working here. So we have to consider here user is sending the data from source to destination, and if any error is occurring during the transmission, then acknowledgement also provided here. So here positive and negative, both the acknowledgement will be considered here. So let's understand this whole scenario of using FSM here. So first we are using the RDT_send method. From that we are making the packet and then we are send that method. Okay, there are the basic three methods we are taking from our first version. So first it will be divided into the two tasks. Wait from, call from above, that is the case where the data is coming from the application layer and sent to our destination. Now what the second event is there, that is the wait for acknowledgement here. So here wait for acknowledgement is all about which data is successfully received at the receiver side or not. So after the completion of successful or unsuccessful completion of our task of sending the packet, it will wait here. And after that our full cycle of data sending is completed. At the receiver side, what happened here? It is only waiting for the data here. If any data after the receiving the data, it will send the acknowledgement to particular source. If any bits of error is occurring in the packet, then it also send the negative acknowledgement. So let's understand all this scenario with the operation of errors and without errors. So understand first what happened here. So first wait for call from the above here. So that is the basic task. At the sender side, our transport layer is waiting for the data from the above layer. Now we understand that already the data is coming, the packet is made, and our UDT_send the data is sending the data using the unutilized channel. Now what happened here next? At the receiver side, it already waiting for the data. That is the state here. Well, we have to consider here two scenarios, if positively and negatively acknowledgement. So if considering the state where the data is successfully sent by our sender, then it will send to the particular part. So RDT_receive the data successfully and it will send the positive acknowledgement and it extract the data here. So that is the case here. After receiving the successfully data item, it will send the positive acknowledgement. Now that is all about the with errors. So that is the part where our data is not successfully received by the receiver. In the terms, if data is not received or data is altered or changed. So what happened here? The first two tasks are same here. First task is all about getting the data. So that is the first case. It is already wait for the data here, and our particular task will be performed here. At the receiver side, it already waiting from the host to receive the data. That is the task. So first two tasks is sent here. Now what happened here? Data is bundled into the one packet. That packet will be sent to particular receiver. But what happened here in the with error scenario? The RDT_receive receive the data, but it is corrupted, or we can say that data is changed here. So what happened here exactly? Negative acknowledgement will be generated here and sent to the particular sender here. So this is the task where the RDT is sending the negative acknowledgement. So when our data is successfully received, at that time positive acknowledgement is given, that is the below part of our receiver side. But when the receiver is receiving the data, that is conclude any errors, then it times it will send the negative acknowledgement. So what happened here? When the negative acknowledgement is received here, it will process again, the cycle will be begin again, it will transfer the data without error now, and it will receive by the receiver, that extract the data again, and then again it will send the positive acknowledgement. That is the case of our RDT with errors here. So in this we have to understand both these things. If negative acknowledgement is occurring here, it will send the NAK here, that is negative acknowledgement. Again the cycle is moving here, sender is sending the data again here, and after the successful data receiving, it also send the positive acknowledgement. So we can say that our data is successfully received at the receiver side with the help of the acknowledgement. So this is the mechanism how we can provide the reliability. But This is all about the protocol basics. But for that, these are the protocols are used by the RDT. So this is the list of protocols which are used by our RDT. It is broadly categorized into the two terms. The first one is noiseless and second one is noisy channel protocols. So when we are talking about the noiseless protocol, it is a simplest protocol. It is categorized into the two parts, simplest protocol and stop and wait protocol. And noisy channel is divided into the three protocols, stop and wait with ARQ, that is automatic request, go back N protocol and selective repeat protocol. In next video, I will explain this protocol in details. So this is all about how the RDT protocol is working. Thank you for watching this video.